Good morning, kiddos. You're probably watching this on Monday, so we are at our last week before Christmas break. So I know we're super excited for break. Please make sure we're pushing through these last 5 days to finish up this unit, take our test. I'm sure you have a lot of stuff to do in other classes, so try and stay motivated, try and stay productive. And I hope you all are wearing your festive fits. I'm wearing my Christmas sweater today and a sequency hat that I have on Friday. Next week is when my outfits really start getting fun, so please make sure you're at our meet so you can see. So we did sequences last week. We took a quiz, and now we're moving on to series. So we're going to start with arithmetic series. And your learning target is I will learn how to find the sum of an arithmetic series. So there's two different ways that we're going to learn how to do it today, but first for a definition, a series, so this applies for geometric and arithmetic. A series is the sum of the elements in a sequence. So our sequences haven't quite gone away, we're just using them in a different way. So for example, a problem might tell us to find the first, I'm sorry, I wrote this wrong. Find the sum of the first 5 terms. And then they'd give you a sequence that is like 2, 4, 6, so on and so forth. So looking at this, we can all look at that and determine our common differences too. And we only want to know the first 5 terms, so we're going to have 2, 4, 6, 8, and then 10. And we want to find the sum, and we know that sum deals with addition. So we'd have 2 plus 4 plus 6 plus 8 plus 10. And if we add all that up together in our calculator, that's going to give us 30. So 30 is the sum of the first 5 terms in that sequence. Easy enough. But what if it asked us to find the sum of the first 115 terms? So it would take us quite a while in our calculator to do 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18, all the way up into the 115th term. So that way we don't have to do that. We do have another formula that we can use. So S sub n, S standing for the word sum, is equal to n times a1 plus a to a sub n all over 2. As always, a1 is your first term. N is the number of terms. So if you have 1 through 115, you're going to have 115 terms you're trying to solve for. So in this format, the sum of the first 115 terms, 115 is going to be your n. And then a sub n is the term value at n. So we'll just do it piece by piece. Our a1, looking at our sequence, is going to be 2. In order to find our an, we're going to have to use that explicit formula that we used last time in our sequences. So a to the n is going to equal our first term plus 115 minus 1 times our common difference of 2. So this is the formula we used last week. So if this doesn't look familiar, turn back into your notes. You're going to put all that in your calculator, and it's going to tell you that the 115th term of the sequence is 230. So when we did find the nth term last week, that was this formula. So we just found the nth term of the 115th, it's 230. And now that I have those two things, I'm able to use my sum formula. So S sub of 115 is equal to 115 times 2 plus 230 divided by 2. You type all that in your calculator, you're going to get the sum of the first 115 terms is 13,340. All right, the same thing here. Another example. if we had the sequence 9, 12, 15, and we wanted to find the sum of the first 36 terms, we would do the same thing. So we have our A1. Our A1 is 9. We're going to have to find our A sub 36. So that's going to equal our first term plus our n minus 1 times our common difference. So 9 plus what's going to give me 12? That's going to be 3. 12 plus 3 also gives me 15. So 3 is my common difference. When I do all that, I get that the 36th term is 114. So now that I have that bits of information, I'm able to do my sum formula. So this is going to be S sub 36 is equal to 36 times 9 plus 114 over 2. You type that in your calculator, and you're going to get that the sum of the first 36 terms is 2,214. So this is a very important formula. Write this down in your notes. Make sure you label it as to what it goes with. So it'll be given to you like this. It'll give you a sequence, and it'll tell you to find the sum of X amount of terms. There's another way it can be given to you, in which is called summation notation. So for summation notation, you're going to have this right here. This is called a sigma in math, or if you know anything about like the Greek alphabet or anything, this is a letter, sigma. And the sigma tells you you're going to find the sum of something. And then at the very bottom, you're going to have your variable. So you're going to have your n. This is going to be your variable. It could be a k, it could be an l. I'm just going to use n. And that's going to be equal to your starting term, essentially. But so don't be confused by this terminology. I'm going to explain it a little bit further, so make sure you're paying attention to what I am saying. The top number is going to be your ending term. And then here in the middle, you're going to have your explicit formula. Okay, so we'll do an example. So you're going to be given something that looks like this. And you are asked to find the sum of this sequence. This is a way of writing sequences. So we are still going to use the same formula we did earlier. So S sub n is equal to n a1 plus a sub n over 2. We're still going to be doing this. So what we have to do first, this bottom number right here, that tells us where our sequence is going to start. It's going to start at the value whenever I plug in 5. So first I have to do 5 times 5 plus 6. That's going to equal 25 plus 6, which is going to give me 31. So this is where my sequence starts. This is going to be my first term of the sequence I'm looking at. So 31 is going to be my A1. And then, now that I have my A1, I have to find my A sub n. So this wants me to go all the way up to 71. So I'm going to do 5 times 71 plus 6. And that is going to equal 361. And that's going to be my A sub n, or my A sub 71. The only thing that is tricky with these is turning in your variable for right here, or filling in your variable right here. So essentially, I'm starting at n equals 5. That's my first term. So when n equals 6, that's going to be my second term, third term, fourth term, so on and so forth. So your n right here is not 71, because this wants you to have the total number of elements that are in that sequence. So if we start at 5 and go to 71, there's not going to be 71 terms, because I didn't start at 1. So that doesn't make sense. Kind of play that back because I know that is kind of confusing. There is a formula to find your n when you're dealing it with summation notation, excuse me. So it's going to be, to find your n, it's your ending value minus your starting plus 1. So I want to find my n. I'm going to do 71 minus 5 plus 1, which is going to equal 67. So a way to think about that is if I listed out like 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the way up to 71, and I counted out how many numbers I had written out, I would have only written out 67 numbers. So now that I have all this, I'm able to use this formula. So that's going to give me 67 times 31 plus 361 over 2. And I type that in my calculator, and that's going to tell me that the sum of my first, from 5 to 71, all 67 of those terms is going to be 13,132. So let's do another example. If I'm given my sigma 65 n equals 1, 5n plus 3. And they won't always be 5n plus something. They just happen to be the two examples I picked were. So we want to first start with our a sub 1. Our a sub 1 is going to be whatever number that is at the bottom. So we want to find 5, 1 plus 3 is going to give me 8. And then I need to find my a sub n. So my a of 65 is going to be 5 times 65 plus 3, which is going to give me 328. So now I need to find my n value. So my n is going to equal my ending value, 65, minus my starting, plus 1. So in this case, because I'm starting at n equals 1, they are going to be the same. But it is not always the case like that, so I recommend checking yourself with this formula. So now that I have all my bits and pieces, I'm ready to go. So S sub of 65 is going to equal 65 times 8 plus 328 over 2. And you're going to plug that in your calculator, and the sum of those first 65 terms is going to be 10,920. So you are going to get pretty big numbers when you're doing these. That doesn't mean you did it wrong. That's just kind of the nature of the beast. So I think we're going to be okay when we're dealing with, I don't know where my notes went for this. Oh, here they are. When we're dealing with where it says, gives us the whole sequence, and it tells us to just plug in this formula. I know that the summation notation stuff might look kind of scary, but I promise it's really not that bad. But if you are confused, please, 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 come ask for help. That's what I'm here for. So there is going to be 6 practice problems on summation and 6 practice problems on just the regular sequence and Delta Math today. We are kind of moving pretty fast to finish out this week, so please make sure you are doing this assignment in a timely and productive manner. If you need help, please come ask for it. But if I don't talk to you the rest of the day, I hope you have a great Monday, and I hope you're staying motivated today. If you need anything, please come ask. Talk to you all later. Bye.